I've been studying interstellar objects for over 10 years. I witnessed the hysteria surrounding ʻOumuamua when half the scientific world tried to fit its strange acceleration into the framework of evaporating ice, while the other half whispered papers about solar sails. I read the first rough reports on 2I/Borisov when everyone suddenly realized that interstellar visitors were not the exception, but the rule. And then 3I/ATLAS came along, and that's where everything went wrong. Technically, it was just another hyperbolic orbit, another strange visitor with a green coma, too active, too far from the sun. Its reports looked as expected: parafocus, velocity, inclination, spectrum, outgassing. Not a single word about someone, somewhere, making a mistake that would force us to reconsider the very concept of a random flyby. The first warning signs didn't come from NASA or ESA. They came from a quiet, almost boring spreadsheet, a perfectly ordinary attempt to do what astronomers do all the time: gather all known interstellar objects into a single model and see how they behaved before they encountered us. It was routine. A 20-page article, 10 authors, a ton of graphs. We received similar drafts every week, but this letter was addressed to me personally with a short accompanying note from a colleague in Chile. Please take a look. We have a feeling the simulator is going crazy. I opened the attached archive, expecting to see another debate over initial conditions. Instead, I saw a carefully constructed backward integration of the trajectories of ʻOumuamua, 2I/Borisov, several lesser-known candidates, and fresh data from 3I/ATLAS. The gist was simple. If you rewind orbits millions of years, taking into account the gravity of the sun, planets, galactic tides, and known flybys of nearby stars, interstellar objects should fly off to different locations, like marbles released from one room into a vast hall. This is how the models always worked: no particular organization, just a statistical cloud of initial directions. But something else was happening here. Before 3I/ATLAS was added to the database, the orbits of ʻOumuamua and 2I/Borisov behaved as expected, chaotic, with enormous uncertainties. But as soon as the third object's new parameters were added and the integrator was run, accounting for all the errors, the cloud of possible past positions began to shrink. The graph they sent me looked almost indecent. It showed a few colored spots, the probabilities of where each object was 10, 20, 40 million years ago. Without ATLAS, they were smeared blobs against the galaxy's backdrop. With Atlas, the inflated sphere transformed into an elongated cloud, and then into something else entirely. Intersecting volumes gradually converging into a single region of space far beyond the Oort cloud. None of the objects hit the target exactly, but their probability tails, those long, thin error lines, began to intersect. With each model run, with each refinement of the Atlas parameters, the intersection became more and more consistent. "It's just an artifact," I said out loud to the empty office, "an adjustment dependent on the initial conditions." I emailed the authors, asked for the full code, and checked that they hadn't included anything exotic in the model. No modified gravity, no hidden mass. Everything was perfectly classical. Newton, Einstein, the galactic tide, the known stars. And yet, even with Atlas correctly taken into account, all of our interstellar visitors, at least those whose orbits were measured with sufficient precision, remembered a single region. Not a single point, no. A vast one, spread across millions of astronomical units, but common to all. As if they hadn't just flown in from random directions, as if they had once been part of something greater. I tried to convince myself it was just a pretty visual effect. A multi-dimensional error in the parameters produced strange projections. But the deeper we dug, the less it seemed like a coincidence. Colleagues connected ALMA. Under normal circumstances, radio telescopes don't chase a point somewhere far beyond the edge of the Oort cloud. There's nothing there. There are no bright radio galaxies, no active nuclei, no powerful quasars. It's a very distant, very monotonous sky. We took the resulting intersection region, a huge yet finite chunk of space, and asked ALMA to look there. Not at Atlas, not at ʻOumuamua, but at that hypothetical region where their paths might once have crossed. I remember sitting in a dark room in Santiago, staring at the gray-green bands of the fresh spectrum. Usually, you don't look at such graphs with your own eyes. It's all decided by algorithms anyway. But this time, everyone wanted to see it first. At first, there was just noise on the screen, that honest, boring thermal noise that any radio instrument sends into the channel while staring into space. Then something happened that I'd never seen in my entire career. The noise began to break. Not in the physical sense, of course. The histogram remained flat, the amplitude distribution normal. But when we began to decompose it by frequency, by time patterns, by phase shifts, familiar structures suddenly began to emerge within the nothing. At first, these were vague bursts in the ranges where ʻOumuamua had previously been detected. Narrow peaks, reminiscent of those strange non-gravitational accelerations explained by jet gas emissions, but also fitting perfectly with the thin sail model. Then signatures began to appear that were remarkably similar to the dust-tail profiles of 2E Borisov. Asymmetrical lines, hints of complex chemical compositions, were characteristic only of it. We superimposed the archival spectra and, for the first time in our lives, saw radio echoes of objects that had long since left our system. It was as if someone had collected the finest traces of each passing visitor, blended them, and now played them back over a colossal distance, in the barely perceptible whisper of the millimeter range. "That's impossible," someone said behind me, and this wasn't just a figure of speech. For such signatures to have accumulated naturally, all these objects would have had to have either formed close together or interacted in some way in the past. But according to our previous models, this seemed unlikely. The raw data arrived from ALMA. We sent it to independent groups in Europe, the US, and Asia. A week later, the responses were the same. This wasn't a processing artifact. In the millimeter range, from a quiet, unremarkable sector of the galaxy, a radio echo was coming, within which the familiar spectral signatures of all interstellar objects we knew about were discernible. Not just ʻOumuamua and 2I/Borisov, even faint candidates, barely extracted from the noise, left their imprint in this echo. Some called it a trajectory graveyard, others called it a radio morgue. I preferred another metaphor. It was a log, as if, somewhere far away, there existed a system that was obligated to keep a log of all the packets that passed through its border, and 3I/ATLAS was the last, most striking line in this magazine. We started all over again. We ran the trajectories again. We refined the region again. We asked ALMA to increase its sensitivity again, adjust its antenna configuration, and filter out everything that could be filtered out. The more we looked, the more clearly the structure became apparent. It wasn't just noise mixed with familiar lines, it was a multi-layered signal. One layer was the background, with the signatures of all the objects that had already passed. The other was a slow, deep, monotonous component, reminiscent of the breathing of something very large and very old. Superimposed on it were flashes, very similar to short, directed transmissions, each of which could have been written off as random, if not for one detail. The time intervals between them were synchronized with the position of 3I/ATLAS in our system. Every time ATLAS crossed certain heliocentric longitudes, the echo signal changed. It was as if our interstellar visitor were not just another entry in a log, but an active cursor moving through the log and updating its contents. A split began within the group. Some said this is natural in any case. Perhaps we are observing a complex tale of interactions between interstellar clouds, the remains of protostellar disks, and weak shockwaves. With enough data, anything can be combined into a single, magic signal. The others remained silent. They were satisfied with the fact that this time, the coincidences were not only in frequency and shape, but also in timing, phase, and Atlas's position in our system. We tried to imagine a different map. Not a map of stars, not the Oort cloud, not a spiral arm of a galaxy, but a map of landmarks, as if somewhere in the darkness there existed an invisible network that tracked every object that crossed some invisible boundary. ʻOumuamua is the first entry, then 2I/Borisov, then a few more less noticeable ones. And here it is, Atlas, the last bright ping. If we take this hypothesis seriously, we have to ask an unpleasant question: where is this boundary? When we extrapolated the intersection region of the trajectories even further, beyond our usual models, the same spot kept emerging. Not a specific point, not a pretty ball with a cross, but a stable volume, where the probability density of the past of all objects was at its maximum. It lay far beyond the formal boundary of the Oort cloud, beyond what we've come to consider the edge of the solar system, where the sun's gravity barely holds anything together and the galactic tide has long played a dominant role. If I were a romantic, I would say there, at the edge of our gravitational shadow, there is a gate. Of course, we didn't say this out loud. The articles used careful phrases, a common region of possible origin, correlated trajectories given new data, complex structure of the interstellar medium, but at night, when we remained in the room with the monitors in silence, no one could seriously utter the word chance without feeling it hanging awkwardly in the air. Then questions started coming from above. First, neutral ones. Confirm that you have not made any assumptions about the presence of artificial sources. Then, more stringent ones. Do not use terms in public reports that could be interpreted as implying the intelligent nature of the signals. We didn't intend to. Frankly, the very idea of intelligent nature seemed too human, too insignificant. What emanated from the point where our trajectories converged seemed less like a message and more like a function. Imagine interstellar space not as a void, but as a gigantic logical layer. Objects move through it. Comets, debris, ice flows, perhaps even spacecraft. Most simply pass through, leaving behind minimal traces. But some, those that for one reason or another cross the required boundary, are marked. A mark doesn't necessarily mean we see you. It could mean you've entered an area where different rules apply. Atlas appears to have been the last such marker in our time window. ALMA continued listening. We had accumulated enough data to take another step, one that many would later call fateful. One of our radio engineers suggested doing something we had previously avoided, not just passively listening, but responding. I don't mean sending a "hello, we're humans" signal to that region. That's been done dozens of times, and the universe has politely remained silent. The idea was different, to try a resonance. We knew the frequencies at which the echo signal was most stable. We knew which spectral signatures within it corresponded to ʻOumuamua, which to 2I/Borisov, and which to fainter objects. We synthesized a response that replicated their structure, but added another, new signature to the chain, the one we had already seen in ATLAS. If you've ever tried to forge a password without knowing the algorithm, you'll understand how desperate this sounds. We didn't even know what exactly the system that was giving us its radio echo understood. We simply constructed a sequence in the same style: ʻOumuamua, Borisov, candidates, Atlas, and then added a blank space, like an unfilled cell in a table, and they sent her there, to the very region from which the echo came. Technically, nothing happened. ALMA transmitted faithfully, detected its own signal in the side lobes, and returned to reception. For a couple of days, nothing suspicious happened at all, and then colleagues from the group working on the dynamics of small bodies came to us. They revealed new data. Another object in a hyperbolic orbit had just entered our solar system. Too faint to make headlines, too distant to be noticed by journalists, but clearly enough measured that we could say unequivocally, it's an interstellar visitor. This would be called just a coincidence if not for two facts. First, its calculated trajectory, when back integrated, also passed through the same region where all the others converged. Second, its spectral signature was already in the radio echo that we received before the object was nearby. It was as if the magazine had been updated in advance. Those who believed in randomness said, you just didn't notice it before, and the signal always contained its signature. You only recognized it now. This would have been a fine explanation, if not for one detail. This fragment was not present in the old raw data stored before our response. We checked the control copies, offline archives, mirrors and systems not connected to the network. Everywhere the same thing happened. A section of the spectrum that had previously contained smooth noise now neatly contained a new line. An unknown object, which was just beginning its journey to our system, appeared retroactively in a radio log that we considered a report from the past. Someone quietly said, "Maybe it's not a journal, maybe it's a planner." I didn't want to think in those terms. A planner of what? Ice flow movements? Rock migrations? But the more we looked, the more distinct the feeling became that there wasn't the clear line between past and upcoming flights that we were accustomed to. It's as if each interstellar object isn't a random rock, but an element of some distributed structure stretching across light years, using the gravitational fields of stars and the remnants of protoplanetary disks as a transport network. ʻOumuamua, 2I/Borisov, early candidates, Atlas, and now a new, as yet unnamed guest. In this logic, Atlas truly did seem like the final marker in the chain. Not because it was special in itself, but because it was with it that we first saw the entire chain in its entirety. There is an old astronomical principle: telescopes do not create objects, they only make visible what already exists. The 3I/ATLAS story added a new, unpleasant layer to it. Telescopes, it seems, don't simply peer into a finished picture, they tap into a layer that responds to our observation. Not because a quantum observer changes the result, but because somewhere out there, at the edge of our gravitational shadow, there's a system that takes the existence of the observer into account as a parameter. As long as we believed all interstellar visitors were a random sample from an infinite stream, we could console ourselves with statistics. But as soon as we added Atlas, as soon as we turned on ALMA, as soon as we made a single attempt to respond, statistics turned into structure. And when people ask me what I fear most, aliens or the hidden swarm, I always answer honestly. I'm not afraid that there's a swarm out there somewhere, nor that 3I/ATLAS is its final mark. I'm afraid we've already become part of its internal protocol. simply because we once decided to look too closely and sent back an all too recognizable response. From this point of view, all future interstellar objects that enter our system will no longer be random stones, but packages that received instructions from there, taking into account the fact that there is a planet here covered by telescopes. And one day, among those packets there might be not just an ice shard or a dust ball, but something for which 3I/ATLAS, ʻOumuamua, and 2I/Borisov were merely network ping probes. When it became clear that the new interstellar object was in the radio, echo long before entering the system, people who weren't usually interested in astrometric errors came to us. They didn't have scientific degrees, but they did have clearances we'll never have. They didn't threaten, didn't pressure, didn't play the movie Secret Agent game. They simply asked a few very direct questions. Is it possible, one of them asked, to use this planner to predict the next objects? Theoretically, yes, we replied. If the structure is stable, if the signatures appear in advance, we can try to calculate approximations long before the optics see them. Is it possible to distinguish a natural package from... He paused mid-sentence, clearly searching for the right wording, from what you would call atypical in parameters. And here the room became truly quiet. We all understood what he was asking. Could we tell in advance from the echo signal that it was not a piece of ice and dust flying towards us, but something else? We told the truth. Not yet. The signatures look like a mixture of chemistry, dynamics, and the history of interactions with the field. But, I hesitated. It's already clear that ATLAS, ʻOumuamua, and Borisov all sound different. If we accumulate statistics, it will be possible to differentiate the classes. The man nodded as if he had heard exactly what he wanted. From that moment on, we had less freedom and more resources. We were given access to computing clusters we'd only heard about before. Closed archives of old observations were opened, and we were given nights at telescopes that were usually booked years in advance. In exchange, they took away the right to decide what, when, and in what form we publish. Officially, we were engaged in early detection of interstellar small bodies and risk assessment. Unofficially, we were learning to read the sky's timetable from the quiet, complex, multi-layered signal. ALMA has become more than just a tool. It has become a receiver of system logs. We identified several layers in the echo. The bottom layer is the background, where all the old signatures reside. Above it is a slow, modulated layer that changes with the position of ATLAS and the new objects. And then there are the bursts, short structures in which none of the familiar profiles were discernible. These flashes were rare, but they were now the ones people looked at most often. We didn't know what they meant. Commands, errors, service marks indicating packet delivered, but one fact pierced any skepticism. The timing of these flashes coincided too precisely with the moments when interstellar objects passed through certain geometric configurations, not only relative to the Sun, but also relative to the Earth. Simply put, every time a new guest found himself in a position where he could, at least hypothetically, be clearly detected by our technology, a short, dense, highly organized drop of signal was triggered in the echo. It's like someone's turned on the high-detail logging mode, our radio engineer muttered. We laughed, very forcefully. A couple of months later, it became clear that the new object, the one whose signature had been added retroactively, was on a trajectory that wouldn't bring it dangerously close to any planet. It wasn't a killer asteroid, not an Armageddon-inducing comet. It was an ordinary, by human standards, interstellar rock. That system needed it. We saw how the echo signal restructured itself as it moved. Old signatures changed shape slightly, as if the information was being renormalized to account for the new event. Some components weakened, others strengthened. Imagine a route network with only a few buses. Each trip doesn't just add a line to the map, it slightly alters the entire network. A U-turn is added here, a new traffic light is installed there, and a schedule is adjusted elsewhere. Only in our situation, the road network stretched over tens of thousands of astronomical units, and buses flew at speeds of tens of kilometers per second. At some point, I caught myself thinking of these objects as guess rather than guess. They seem more like data packets traveling through a vast, hidden protocol. Atlas wasn't the biggest, brightest, or most ancient package in this picture. It was simply the package into which our own antenna first fit. We wanted more. We were taught to be careful with our wording, but not with our curiosity. Even when letters from above arrived with gentle warnings, do not actively attempt to interfere with the echo signal structure until a risk assessment is completed. This only fueled the desire to touch the system again. If one of our resonant responses coincided with the appearance of a new object in the journal, what would happen if we tried something more complex? For example, draw a trajectory in the echo signal that doesn't yet exist. We chose a demonstrably safe configuration, a hyperbolic orbit that wouldn't pass close to Earth or any other planet, just a test. A simple question to the system, is this possible? The synthetic profile was hideously complex. It was necessary to combine the signatures of known objects, interpolate their dynamic fingerprints, and maintain those strange proportions we'd already seen in real echoes. What we ended up with was something like a non-existent guest ID, where chemistry, dynamics, and timestamps all came together in a neat yet unobserved combination. And we answered again. ALMA listened. We whispered. The signal strength was negligible by galactic standards, but for local space, it was quite noticeable. There was no lightning, no splash, no dramatic events. Until, a few weeks later, another item popped up in one of the automated reports. A new interstellar object candidate has been discovered. The trajectory is preliminary and requires further clarification. Nothing special. Such reports have appeared once a year since algorithms learned to identify fast, unusual traces against the backdrop of asteroids. Only the preliminary trajectory of this candidate almost exactly repeated the configuration that we drew in the echo signal. We were overwhelmed by a wave of explanations. Just a coincidence. The algorithm picked up our phantoms during cross-comparison. The telescope data is still raw. The errors are huge. We checked. The algorithm was clear. The original frames contained this object even before our transmission. It was already on its trajectory while we were playing the protocols. And here's the radio echo. The old copies made before our experiment didn't contain the signature of this hypothetical visitor. The new ones did, and not only in our observation sector, but also in data, independently saved by other teams. We didn't add it there. It wasn't our faint whispered radio message that changed the gigantic structure. Quite the opposite. The system carefully adjusted the past to our new knowledge so that everything would appear as if it had always been this way. It's as if the protocol we've connected to doesn't just keep a log of events, but strives to maintain a self-consistent history. You can't introduce arbitrary nonsense into it. It either ignores you or rearranges the context so that your package becomes part of the overall logic. And at that moment, I honestly admit, for the first time, I felt truly scared. Not because there's someone out there, not because the interstellar objects turned out to be part of a swarm, because we have proven with our own hands, there exists a structure capable of altering the information fabric of the past in our own archives, in such a way that we won't notice it unless we consciously hunt for inconsistencies. In this picture, 3I/ATLAS ceased to be just a comet. It became a marker of a layer visible to our instruments but defying our notions of time. And if this layer for centuries, for millions of years, kept a log of everyone who crossed the invisible border, then the only truly important question no longer sounded like, what are they? And when will we first appear in their journal, not as observers, but as planned objects? I long thought the worst had already happened. We saw how the past was adapting to the present and realized that our observation protocol was no longer ours. But the present can be more inventive than any imagination. A few weeks after the incident with the phantom trajectory, a new report appeared on our desk. Not on a single object, but on the entire zoo of interstellar visitors that humanity had managed to detect over the past decades, and it was at that moment that the word swarm, once a beautiful metaphor, became all too precise. We plotted all the orbits of ʻOumuamua, 2I/Borisov, and several other controversial candidates, though some considered interstellar, others cautiously dismissed as errors, on a single graph. Then we superimposed the adjusted trajectory of 3I/ATLAS, taking into account the new ALMA radio data, and we saw a simple, almost crude geometry. If we extended them all back, far beyond the Oort cloud, beyond the formal boundary of the solar system, the lines didn't diverge, as expected for independent wanderers, but converged into a single, blurred but distinct region. It wasn't a center in the strict sense, rather it was a thick, multi-layered knot, a place where trajectories became indistinguishable within the error bars. There was no bright star, no black hole, nothing immediately identifiable on the catalog map. It was an ordinary patch of interstellar space, ordinary, until we looked there with ALMA. The antenna cluster fell on this area just as it had previously on Atlas, and the noisy, seemingly indifferent radio background suddenly transformed into a polyphonic chorus. We expected a flat noise with occasional bursts. Instead, we got a complex, layered echo in which all the familiar signatures were distinctly discernible. The characteristic tremor of ʻOumuamua, the gassy, breathing modulation of Borisov, the fresh, not yet established profile of Atlas. And above all this, something else, more massive, deeper, like a bass line, not yet discernible, but which maintains the rhythm of the entire composition. If up until this point we could say we suspected the presence of a common structure, it's now clear these objects aren't chaotic visitors. They're parts of a single, distributed entity, stretching across light years. A swarm, a network, whatever. Their trajectories aren't random passages, but rather threads leading to a single node, one we obviously shouldn't have access to. To our colleagues' credit, we spent the first few hours trying to be honest with ourselves. We assembled a working group and listed the possible sources of error: timescale synchronization, systematic errors in orbital determination, catalog errors, overtrained neural networks seeing patterns where none exist. Anything to avoid accepting the most obvious explanation. But the deeper we dug, the worse it became. Errors surfaced, but not where we'd hoped. They were rooted in calibrations, old software versions, and human typos. We cleaned them out, and the picture only grew more clear. The knot persisted. The radio echo remained multi-component, and the coincidences between the times objects passed through optimal configurations and the characteristic blips in the echo were too precise to be dismissed as chance. The most disturbing thing was that Atlas in this diagram wasn't the beginning of the story, but the last checkmark in the chain. If we ordered the signatures by time and distance to node, it turned out that ʻOumuamua, Borisov, and a couple of forgotten candidates were earlier, distant markers. Atlas was the closest to us in configuration. Like the last point in a long route, it finally coincided with the place where the words, "You are here," suddenly appeared on the map. Government reports, of course, called it something else. A collection of distant point radio sources of interstellar origin, a possible metastable gravitational knot, structured noise. But in the hallways, during smoke breaks, in midnight emails, only one thing was heard: a swarm center. Once the initial excitement had subsided, a careful, almost bureaucratic nightmare began. We were asked to compile 2 different reports. One was for the scientific community, with the nerves stripped away, the wording smoothed out, and without the most outlandish graphs. The second was for internal use, where we had to honestly lay out everything, from signature matches to the likelihood that we were dealing with a controlled system. I spent a long time poring over the final section titled dryly, "Potential Scenarios." It was the most honest piece of writing I've ever written, and the most useless because there was no action plan to be found there. What can you offer if you suddenly discover that all interstellar space around you has long been covered by an invisible logistics network, and your sun is just one of the nodes, quietly marked in someone else's protocol? You can pretend you didn't notice. You can try to hide. You can try to respond. Each option was bad in its own way. We already knew how attempts to respond would end. The journal would erase the past, pretending it had always been this way. Trying to keep quiet sounded rational until you remembered that the swarm had been around for billions of years and probably didn't seriously care about our opinions. All that was left was to pretend, to preserve a normal picture for humanity. Rare visits from interstellar rocks, beautiful photographs of their tails, a couple of high-profile magazine articles labeled "No Panic, No Threat," and somewhere beneath this picture, continue to stare at night at that place beyond the system from which alien roots echo. Some couldn't take it anymore. One of the young analysts working on orbital comparisons simply didn't show up for his shift one day. It turned out he'd quit, handed in his ID, and returned to his provincial university to teach classical celestial mechanics. "At least they don't rewrite the orbits retroactively there," was all he said as he left. Another colleague tried to diffuse the anxiety with dark humor. "Imagine," he said, "if we weren't the first to notice. It's just that the previous ones, the ones who looked too closely, disappeared from the magazine, along with all their catalogs." We knew how to laugh, but every time ALMA detected a new faint signature at the node, another trajectory, another marker, the laughter quickly ended. Because now we knew, somewhere far away, beyond the Oort cloud, on another invisible timeline, it seemed another point had just been added, and Atlas was inevitably approaching its role in this scenario. The closer she approached the system's periphery, the more bizarre the node's radio noise became. The background components associated with ʻOumuamua and Borisov seemed to fade, becoming softer, blending into the overall background. Meanwhile, the portion of the spectrum resembling Atlas, on the contrary, gained power, accumulating harmonics, as if the system were entering focusing mode on the final leg of its route. Sometimes looking at these graphs, I caught myself thinking something seditious. Perhaps the main event has already happened. Perhaps Atlas's appearance in our skies isn't the beginning of something, not a harbinger of the future, but the final line of code written long ago. For us, it's a surprise, a worry, night shifts, whispers in the hallways. For them, it's just confirmation. Another package has arrived, the mark has been placed, the log has been synchronized. We love stories with resolutions too much to accept the idea that in someone's giant distributed system, we are just a side log. And yet, every time ALMA picks up another multi-layered response from the node, in which, against the background of the old echo, a fresh, still rough, but already recognizable voice of a new trajectory suddenly emerges, I shudder at the same thought, which I have not yet dared to write down in any official document. If Atlas is the final marker, does that mean the chain ends there? Or does it mean that after the final marker, a new section is always created in the log? No longer about rocks and ice, but about those civilizations that finally learned to listen to the alien protocol? We expected the node to begin its usual alien behavior, a flare, an emission, something spectacular that could be put on the cover of a press release and called an unprecedented event. But the real strangeness arrived quietly, almost mundanely, in the form of a seemingly boring table of numbers. One of our graduate students, Daniel, was doing something usually assigned to juniors, cross-referencing catalogs, orbits, signatures, timestamps. All of it had to be combined into a single array so the machines could process it without human intervention. He'd sit up all night, fiddling with encodings, complaining about inconsistencies in units of measurement between different archives. That night, he simply came to me pale and silently put the printout on the table. "Look at this," he said. It contained a list of all known interstellar candidates, from ʻOumuamua to Atlas, along with the estimated times when their trajectories in the past passed close enough to the swarm node to logically expect their signatures to appear in the radio echo. Alongside these were the actual times when ALMA detected characteristic bursts in that very node. The coincidences were expected. We'd seen them before. But Daniel added a third column: latency. This was the interval between when the object was calculated to pass through the nodal region and when its signature appeared as an echo in our data. For the ancient visitors, latency was measured in centuries and millennia. Cosmic proportions? Nothing surprising. But the closer we get to our own day, the shorter these intervals become. ʻOumuamua, hundreds of years. 2I/Borisov, tens. One controversial candidate in the Japanese observation archive, several years. Atlas, months. "Do you understand?" he asked. With each new object, the system seems to compress the lag between when an event occurs theirs and when it is recorded ours. I stared at the column of numbers, smoothly approaching zero, and suddenly the thought I'd been avoiding hit me. When the latency reaches zero, it means the node and our monitoring circuit have synchronized. The event log will be updated simultaneously as they pass. No more hindsight. No more comfort that the most important things already happened far in the past. We will look at the sky, and a foreign system will rewrite the map in real time. "Look at the extrapolation," Daniel said quietly. He'd already built it. If we continue the trend, zero would fall on a time interval, uncomfortably close to the date of Atlas's next flyby of the region, where our Sun, Earth, and the swarm node form a nearly perfect alignment. I felt a slight, downright physical nausea, not because it promised some kind of apocalypse, but because the purely mathematical line on the graph suddenly turned into a date after which our sky would cease to be our chronicles. We brought this up at the general seminar. Several people immediately jumped on the methodology. Correlation, sampling, statistics, you can fit any line to any point cloud. All true. Science should bite. But the more people recalculated the data, the fewer arguments against it remained. The lag was indeed falling. And if we didn't factor in a miraculous trend reversal, synchronization was a matter of not centuries, but the next few years. Someone tried jokingly calling it a moment of onlineness, suggesting that until now, we'd been living in an offline version of the universe, and that soon we'd be connected to a live server. The joke didn't catch on. From that day on, the atmosphere in the group changed. We no longer argued about whether there's someone there or not. Suddenly, that became secondary. A far more important question became, what exactly is this swarm doing besides marking the passage of bodies? The simple picture of a route network was cracking. If it were a purely transport protocol for rocks and ice, it wouldn't have cared whether we noticed it or not. But our attempt to intervene, a synthetic trajectory, a phantom candidate, and now, a falling lag, as if the system is adjusting the update rate to our observation capabilities. One night, I caught myself looking at the node map the way I used to look at brain activity on an MRI, layer by layer, zone by zone. Somewhere old faded signatures of long ago flights, somewhere fresh bright traces of the last objects, somewhere zones of increased activity where the echoes vibrated more frequently and complexly. If we imagine that this is not an abstract space, but the cortex, the subcortex, the centers, the conducting pathways, the thought became too obvious to dismiss. Doesn't this all resemble a huge nervous system stretching across light years, where interstellar objects are just impulses along the fibers? Of course, it was just a comparison, a figure of speech, but somewhere deep down, I knew that such analogies don't just happen. To their credit, the higher-ups began to seriously consider the question of what to do. Inquiries began pouring into private chats. Could this protocol be used to their advantage? Could, for example, the coordinates of some dangerous asteroid be embedded in an echo signal, as if relaying a notification upward? There's a route error, a corrector is needed. In other words, is it possible to ask the swarm to move the rock before it hits us? On paper, it looked like the perfect insurance policy for civilization. In reality, it was a plea for an unknown system to intervene in our history of body movement. Did we have the moral right to ask for such a thing? And even more frightening, did we have the right not to ask if such a possibility really existed? I understood that we had reached a point beyond which there would be no more non-interference. Either we continue to quietly observe, pretending not to see all this, and at some point we simply wake up in a world where celestial mechanics has become subject to someone else's schedule. Or we ourselves become participants in the protocol, and all this despite the fact that we still didn't fully know whose protocol it was. Sometimes, after staying at the observatory until morning, I'd go outside, sit on the cold concrete, and look at the sky, no longer as an astronomer, but as an ordinary person. No graphs, no logs, no nodal structures. The stars were in their places. The constellations remained unchanged. There was no trace that somewhere out there, behind the familiar pattern, someone had been carefully keeping a billion-year-old journal, and we had just accidentally discovered access to it. If it weren't for ALMA, the Hubble archives, or this weird math, I, like billions of others, would live in a world where interstellar visitors are simply a rare, beautiful phenomenon. Perhaps this is exactly the kind of world we should preserve, but there was no turning back. Atlas continued its hyperbola. The swarm node increasingly illuminated its signature. Latency continued to decrease, and one night, when we were once again listening to the radio noise from that distant node, a change appeared on the screen that could not be explained by lags, calibration, or human error. A new, thin, but clearly structured component appeared in the echo signal spectrum, among the layers corresponding to old and new objects. It was unlike any known interstellar body profile. Its shape was suspiciously reminiscent of our own total radio noise, that very portrait of the Earth that is obtained if you add up all our transmissions, television signals, radars, and probe channels over the past decades. It's as if, somewhere far away in the swarm, someone finally clicked the synchronize this node checkbox, and our signal officially became part of someone else's log. We looked at the schedule, at someone else's protocol, in which our own signature clearly appeared for the first time, and we understood. Whoever controls the swarm, whatever this node is, a network, an organism, an archive, we have already entered its structure. Atlas merely pushed open a door that may have been ajar for a long time. Now all that remains is to wait until another component appears in the same echo signal, next to our outdated radio portraits, one in which the node will begin to reflect not only our past signals, but also future ones. And then perhaps, for the first time, we will see what the history of a civilization looks like when it is not written by itself. We weren't going to wait passively. As soon as it became clear that the node was now harboring not only an alien echo, but also our own radio fingerprint, the group naturally split into two camps. Some said, let's stop, record the fact, let the next generations deal with it. Others, and I was among them, understood that this wasn't the case. If you already see a structure, you'll still dig a little deeper, at least a millimeter, just to make sure there isn't another one underneath. The first thing we did was throw out the idea of waiting for the node to begin reflecting the future. It's a nice phrase, but in reality, no one will hand us an envelope marked, "Here, this is tomorrow's news." We took the opposite approach. We took the node's fresh spectrum, isolated the components similar to the Earth's overall noise, and tried to subtract from it everything we already knew. It was a monstrous undertaking. We had to collect archives of broadcasts, radars, navigation systems, satellite communications noise, even signals from old military early warning systems, everything that had ever been transmitted from Earth and could, hypothetically, be reflected in the swarm. The machines gnawed on this debris for weeks until a hatchling was born, a cleaned profile, which would be devoid of anything we had already produced. We really wanted to see zero there, emptiness. To calmly say, the node honestly reflects only the past. There are no predictions, all other fears are projections, but it didn't come to zero. The graphs that emerged after subtraction contained faint but persistently repeating patterns. Not continuous noise, but a collection of islands, fragments of modulations, fragments of spectra, brief sections like blinks that were clearly not processing artifacts. At first, we assumed these were simply gaps in our database. We'd overlooked some bands, forgotten rare formats, and failed to cover the entire zoo of human radio technology, but the more we expanded our database, the more stubbornly these isolated pockets of survival became. Then, one of our signal specialists, Amelia, suggested something seemingly idiotic. Let's count styles, not frequencies. She trained a network that could guess the type of equipment it belonged to based on just a few milliseconds of a signal. Which satellites, which antennas, which protocols. We threw the remnants of the nodal profile at it and braced ourselves for a ton of errors. The network did indeed make mistakes, but not randomly. Time after time, it returned strange, frighteningly specific answers. Satellite models that didn't yet exist, radars that hadn't been launched, call sign sequences that weren't yet listed in any registry. From a technical standpoint, this could be attributed to the neural network hallucinating, constructing variants based on what it already knows. Any honest specialist will tell you that's how it works. But when we started writing down these hallucinations in a column, it turned out that some of them were suspiciously similar to what was currently being discussed in closed projects. A country that hasn't yet officially announced its new navigation constellation, but the characteristic pattern of its future frequencies is already present in the nodal echo. A company is just applying for frequencies for a future constellation of small communication satellites, and suddenly we see a signal in the spectrum that perfectly matches the range and modulation type they're discussing in private correspondence. Someone, of course, might have suspected a leak, espionage, human error. But ALMA was listening to a node outside the solar system. If there was a leak, it was in a direction where our usual systems break down. We sat in a dimly lit room and looked at these columns. Possible future satellites, radars not yet built, mission not yet in existence. It was all thin, barely discernible threads, but they were there. Maybe this isn't the future, but simply options, one of the theorists said cautiously. The protocol stores not only what has already happened, but also what might yet happen, and reflects back to us the configuration space. It sounded beautiful, and perhaps even true. There was just one small catch. A few weeks later, one of the variant threads coincided with a reality. A news report announced a new exploration mission to the outer planets. The design documentation, later made publicly available, listed the frequencies of the primary interplanetary communication channel. They almost exactly matched one of the phantom modulations we'd seen in the node's profile prior to the announcement. One could say it was a coincidence that engineers around the world aren't all that original, all gravitating toward the same solutions. One could. But after everything we'd already seen, the word coincidence sounded like a poor excuse. And then we were faced with a new, far more unpleasant question. Does the node pick up our future events as soon as they are born in our heads in drafts? Or does it, on the contrary, impose on us those configurations that are already recorded in its own journal? If the latter, then we haven't simply found someone else's protocol. We found a template that our history quietly bends to, long before we even realize we've made a decision. It was a point at which even the most cynical of us began to wonder whether we should continue digging at all. We could have called it a day, write a dry report on the strange correlations, request another telescope, and call it a day. But the problem was, ATLAS was still running. The node was still alive. And whether we were watching or not, the alien log continued to fill, including our signature. One evening, when the discussion had reached a dead end again, our senior colleague, who had been silent until then, suddenly intervened. He was one of those people who remembers the time when spectra were printed on paper and carried through the corridors in hand. "You know," he said, "I've been watching for 30 years how the universe doesn't care about our wishes. Whether we like it or not, planets move, stars explode, comets fly by. We were sure that at least this was fair. We were hit. That means our orbits just align. It happens." He turned the screen towards us with the node, with our phantom signatures, with the atlas lines and all the lost guests converging in one distant area. And now, we see something that might be interested, not in us specifically, but in the very fact that we can see it, and unlike the Sun or Jupiter, it can change our map retroactively. So, he sighed, "It seems to me the only honest position here is to admit that we don't even know at what point we stop being mere observers." He was right, but this admission did not provide a recipe. Ultimately, a compromise emerged. We continued listening to the node, but imposed a strict moratorium on any active responses. No more resonant outbursts, no more attempts to map a trajectory. We limited ourselves to the role of readers who had accidentally been given a piece of someone else's journal. Meanwhile, Atlas had passed its minimum distance and was beginning to drift away, to a point where its tail would be too weak for even our best antennas. It was mentioned less and less in the news. There was an interstellar visitor, glowing, beautifully green, passed, gone. Thank you, next one, please. But for us, it remained the last visible mark in the chain. The object around which it suddenly became possible to see that the entire history of interstellar travelers in our system is not a collection of coincidences, but part of a vast structure, larger than us and longer running than us. Sometimes at night, when ALMA produces another series of data on the node, I again open those graphs where the trajectories of all the lost guests are poured into one node. ʻOumuamua, Borisov, unnamed candidates, and now Atlas as well. And every time I catch the same thought that I can't get rid of. We called them lost because we couldn't trace their path beyond the system. but perhaps we are the side where the connection with the swarm truly breaks. And there, on the other side, no visitors ever got lost. They simply followed their routes, leaving marks in a log that needs neither our names nor our fears. And the only thing that truly changed with the appearance of Atlas was that for the first time, the magazine turned one page towards us and allowed us to read the first line, where instead of a set of alien identifiers, something painfully familiar flashed. The faint, trembling silhouette of our own planet, inscribed in the swarm protocol along with any other objects. I don't know if this will be a comfort or a source of horror for anyone. For me, it's a reminder that we live in a world where being seen doesn't necessarily mean being understood. Sometimes it just means someone, somewhere very far away, has carefully put you on record.